Kia ora and welcome to Forest Call, Forestry Telling Its Story. This episode we see how Scion in Christchurch have been wiring up the antennae of a live, albeit sedated, moth. The moth is male, so it's incredibly sensitive to pheromones in the air put out by the females, but when the moth is captured, put into an electronic box which is connected to an oscilloscope, the pheromone signals can be used in a way quite contrary to the male moth's purpose in receiving them. No longer are the female moths to be found to mate with, rather an exotic incursion of them can be quickly found so we can wipe them out. That's all still to come. First up, we welcome Geoff Thompson. Geoff, thank you for joining us on Forest Call. You're the chair of the Forest Growers Levy Trust. What on earth is that organisation?
Yeah, well, thank you, Don. Thanks for having me. The trust is a result of a lot of pressure applied within the forestry industry about 6 or 8 years ago to be more self-sufficient in terms of the funding of its requirements, research, biosecurity and other activities. So we had a referendum in 2013, had substantial approval.
This is under the Commodity Levies Act.
Yes, yes. And in conjunction with the government at the time, we had approval for by 84% of both numbers and volume. The big fellas, the corporates, and the small-scale forest growers said, yes, proceed with this. So now about 60% of the money collected, which is running at about 9 million a year, is used for research purposes, largely through Scion, improving productivity and quality, but we do a lot of other things. And you might remember that a few years ago there were the horrendous safety figures. Well, we promoted from that time the establishment of a safety council, Forest Industry Safety Council, FISC, and we've largely funded it alongside ACC. That is the sort of achievement. We fund surveillance of all forestry, big and small. It's a facility that benefits all forestry, and that's why it's a universal levy. Nobody can avoid it. There's a lot more emphasis going into training and provision of more labour, expert labour, to the industry. There's a great need for that, and especially in East Coast, you might have noticed recently the government has, Mr Jones, the Minister, has announced a support of a training school, an on-the-job training school. Well, that is to be commended because there's a shortage of labour in forestry and there's a lot of expertise required. Machinery, technology, those sort of things are being introduced as well.
So we've got research, we've got biosecurity, we've got health and safety, and now you're talking about careers and training, but there are other activities as well, such as research into and awareness of fire, of safety on log trucks, a few other activities
yes,
as well.
Yes, fire, we run a program, a TV program that, we back a TV program about fire safety. We have a program that backs transport safety and engage in the arguments about rating for rural roads and things like that.
So there's advocacy stuff that goes on as well.
A little bit of advocacy. We don't take up advocacy for the industry generally. That's undertaken by the groups, the Forest Owners Association and the New Zealand Farm Forestry Association. But we take up promotion of the industry generally, all the industry good things we do a lot of work behind the groups that are doing that.
So the levy comes up for a new order. The vote of those eligible foresters at the beginning of next year. Your message to them, those potential voters?
The important thing is to participate, and this effort that we're making to promote the existence and the continuity of the levy is what we're getting into now. The levy will be, or the referendum, will be undertaken next April. So there's quite a build-up. There will be a number of regional meetings where the story will be promoted. There will be public advertising. There are articles in magazines. And so we are making it known amongst the industry, the growers. We think on the trust that it's been quite successful. The spread has been broad and of value, and we want to see it continue.
Geoff, I'd just also like to point out, as part of the information campaign on the levy, that we have now established a website. We've got the URL for that website, so all the information you'd want to know about how that levy works, what it's spent on, what the investment value is in it, go to that URL. And Geoff, if I could take you off on something of another tangent here, and that is that now with the Productivity Commission and a big part of the billion trees, it's carbon sequestration, particularly in our planted pine forests. How important is that for people in forestry to get their heads around? It's no longer just for the timber.
Well, that's right. The whole climate change debate has turned its focus onto forestry. The interesting thing is that the Productivity Commission, the MPI, the Climate Change Minister, the Minister of Forestry all recognise that forestry provides, through the magic of photosynthesis, a way of capturing carbon out of the atmosphere and locking it up. What happens, what has happened is we've got recommendation for planting millions of hectares of more trees. How do you encourage people to do that? And we are promoting the idea that there is supplementary income beyond what is a very good industry now, which is the harvesting of the logs and dealing with those internally or externally. But we're going through a review, and we're helping out with that, of the rules that apply to forestry and how you can earn New Zealand carbon units, which are increasing fast in price. And the interesting thing is, I just read today, for instance, that Britain is coming to very much the same conclusion, that the best response they can make to the climate change worries and the carbon in the atmosphere is plant more trees. And so we're on the side of the angels with this one. We've got magnificent forests here, but we've had exotic forests, and we are mainly interested in plantation forestry. We've had that in New Zealand for over 150 years. And while we don't expect the countryside to be plastered in exotic pine trees, we do recognise that they are easy to grow. New Zealand are world leaders in the establishment and management of Pinus radiata forests, and it's one of our most important industries, and it's wonderful to see it being recognised now as a great contributor, not just to economic well-being, but to environmental well-being, and that's what we've got.
Geoff Thompson, thank you for joining us on Forest Call.
Thank you, Don.
Our planted forest industry, challenging to be our second primary export earner. Wood's environmentally good in plant and product for building and landscapes. We're great in technology and science, selecting stronger, straighter trees, safer ways to harvest them, cleaner and earthquake-resistant ways to build. Forests, regionally vital for economic development, creating all sorts of jobs. A prime future investment for our nation. Love our forests. Our forest product exports hit $6 billion worth this year for the first time ever. That's more than the combined value of sheep meat and beef exports, which are usually identified as our second highest value export industry. Much of our forest estate, however, is found on the very same farms and planted by the very same farmers who run those sheep and beef. In common with hill country farmers again, we share concerns about biosecurity, the pests and diseases we don't have, but which, if we did get them here, could devastate both our forests and amenity and our horticulture production as well. For example, myrtle rust, which arrived in New Zealand last year. It's a fungus which threatens our eucalyptus plantations, our feijoa orchards, and our native trees such as pohutakawa and ramarama in particular. So far it looks like the strain of myrtle rust is not suited to our climate, and the immediate threat of significant damage to forests or crops is not major. In today's Forest Call, we look not so much at particular diseases or insects, but rather at what clever things will keep them out, or if they do arrive here, find them and eliminate them before they multiply up and establish. The periodic arrivals of painted apple moth or Queensland fruit fly in urban Auckland remind us that the front line for primary industry biosecurity is in our cities. So Scion scientists in Christchurch are building what they call a toolkit for the urban battlefield. The principle behind it is fighting a new pest or insect is both a technical and a social challenge. So get in early and prepare for the incursion during the calm.
As quickly as possible, and that comes all the way back to the active surveillance, find it fast. So go out and seek it rather than have it be passive. Comes back to the targeted spraying. So we have tools ready to go that are small and concise to get those populations. That helps protect the environment. That helps with the social license to operate. People are hopefully more willing to accept that. And then you have the engagement protocols. So really improving the engagement during the calm and then also in the battle. If the population of the pest can be found quickly, then the population is smaller and the chances for eradication have increased. So this program is about developing a tool to find that population, where it is, where it's sitting, how far has it spread.
That early detection goal takes us now into the Scion labs at Christchurch. Brooke is wiring up a live moth into a cyborg to detect more moths, and it's quite a process.
The first thing we do is to take a notch out of the foam for the moth to fit into. Now I'm going to get the moth. It's a light brown apple moth and it's a male. And now we'll sedate the moth. And now I'll install the moth into the cyborg. And continue on under the microscope. I'm going to take the very tip of the antenna and connect it with gel. And he's connected. And to complete the setup, I'm going to attach the ear cover, the fan, and the aerial. And now it's time to see the signals from the moth.
Everybody knows pheromone traps have been used for this purpose for ages, so why do we need to do anything else?
Well, there's nothing particularly wrong with the traps per se. They work very well when we already know what the pheromone is. So, for example, the gypsy moth, which is a pest that likes to eat trees, we have a trapping network of several thousand traps around New Zealand looking for it, and we already know what that pheromone is. But say, for example, we have a new incursion of an unwanted insect species, and we don't know what the pheromone is, we can't really have a trapping system to be able to find them. So in that case, we can use a cyborg, and this is what we've been developing here at Scion with some assistance from the University of Canterbury and InFact, an engineering company here in Christchurch. And effectively what we're doing is we're using the insect's own sensing system. So we're using the antenna of the insect, which is finely attuned from evolution to be able to find the pheromones that the female's producing. So the male moths are incredibly sensitive to find the female moths. So effectively we're using the male moth as a sensor inside our system here, and all the rest of it is just the electronics to allow us to snoop in and say, aha, you know, the moth has seen or detected a pheromone.
How sensitive is that antenna in the moth?
Well, it varies between species, but one of our technicians, Brooke, has just recently been in Canada and she's been using it on the gypsy moth, and we've been finding detection levels down to a picogram level. So that's a very small number, 1 to 10 to the minus 12. So to put that into perspective, if you were to find a little 1 cubic centimetre block, it's equivalent of finding one of those in a rugby pitch that's 147 metres deep. So incredibly sensitive. And we have a fan on the edge of the tube here, which is sucking air past the moth, and that's the air that the moth is sampling. Effectively, the rest of it down in here is a series of amplifiers. So you can think of it like your stereo. You know, you want to listen to something at loud volume, you turn it up. And what we're doing here is we're picking up very, very small electrical signals off the antenna, and the amplifiers allow us to detect those.
So now out in the field, Steve, we've got Jess with a cyborg. What are we doing here?
Right, so Brooke hooked up a moth in the lab, and what we're seeing here is a couple of traces. So this is effectively the electrical signals that are coming from the moth. And what we have here is 2 lines, so each line represents one of the antennae of the moth. So we're constantly monitoring both of those antennae of the moth as Jess is there walking around. And if it detects a pheromone, we should see a peak occur on here. So
a tiny little antennae and a very small moth is being transmitted onto the PC screen.
Yep. Eventually what we want to get to is we want to integrate this sensor, which is effectively a yes-no sensor, with some logic that the insects use in the real world to try and find the male to try and find the female. So they use certain strategies like zigzagging up a plume in the air, and if they miss it they might do a spiral cast getting bigger and bigger until they re-intercept the pheromone. So globally there's been quite a bit of work done on the kind of algorithms to try and predict and find those things. So we want to integrate those algorithms into this unit so we can hook it up onto, say, a drone or a small blimp, and we can get that algorithm to actually drive the cyborg to try and find the female.
If we look now at then what you call social license to operate, again you've differentiated between a battlefield and a calm. What's the difference?
Getting them to understand the total impact of that pest. It's not just about the economic side of things, it's actually about total exposure to spray should the pest establish. Now we have to spray that pest for control because our export partners won't take our products anymore, for example, unless we do keep it under control. It's about talking in the COM about biosecurity, gaining support for biosecurity for New Zealand during the COM, and then if there is an eradication, the community has already been brought on board and they understand the process, so they're not coming in at it cold.
So in our project we're looking at a number of things, one of them being how do you engage with communities and how do you communicate with them effectively. So one, that's about understanding what communities want to know and how they want to be spoken to or how they want to interact with agencies, but also about understanding how agencies interact and what they can do better. And understanding that before the storm is really important, because obviously in the heat of an incursion, it's really hard to communicate effectively and to make sure that you're meeting the needs of communities. So pre-incursion, in the calm, we're trying to understand the best way to communicate with communities.
That implies if you're going to do work during this, what you call the calm period, that agencies haven't done a particularly good job of that in the past?
In the past, some communities feel like they haven't been communicated with effectively, that they haven't had access to all the information that they want. And so now what we're trying to do is understand what the information is that communities want, how they want to be communicated with, and what role they want to play in incursions. So ensuring that agencies understand all those various needs and the various communities that exist within a wider urban context, and helping them plan pre-incursion to ensure that they can respond effectively.
If you move then into the incursion phase itself, what communications are you looking at there?
Communities want to know how the particular incursion affects them, what it means for them in their day-to-day life, i.e. there are restrictions in place, maybe they can't go certain places or purchase or move food, but they also want to know about chemicals that may be used. They want to know why people are in their yards and how long those people are going to be in there. So more and more complex questions about actual incursions as well, wanting to know what the pathogen or the disease or the pest is, but also what that means specifically for them and how long is this going to interfere with my life. And that varies across an urban space where there are lots of communities of interest. And so if it's a community that are attached to a specific native environment or a natural setting, they might be more interested in the social impacts of the incursion, and others may be cultural impacts of an incursion. So understanding all of those aspects, whether it's economic, environmental, social, cultural, is equally important.
It's also a program, once that pest has been found, to spray. How can we spray in a targeted manner? So not using the big DC-10 aerial spraying, keeping that for the worst case scenario. How can we go in and spray and eliminate this pest in a very precise, targeted manner? So the urban environment has many different types of host plant species. It has tall trees and short trees. It has a suburban feel or a downtown city feel, many parks. And so the idea is, what can we use in a targeted area to go after these pests?
We've actually got two technologies we've been working on. One is a helicopter and the other is looking at UAV platform for spraying.
Well, Christina, can you tell us about the use of the UAVs, the drones?
Yes, well at Scion we are focusing on investigating using smaller rotorcrafts like multi-rotor UAVs for eradication purposes. So what we're focusing on is to understand the interaction, for example, of the swirling flows around the rotors on the spray dispersion in confined spaces, like for example in urban environments.
So how difficult does it become having a wash from the propellers when you try?
Oh, it's highly chaotic. It's really unpredictable, to be honest. You see, there are so many combinations of different rotor systems. You have quadcopters, octocopters, you have coaxial configuration on top of each other, and they are all creating a highly unpredictable system of vortices and downwash strengths. If you have a small incursion, you want to just spray where the incursion occurs and not, everywhere else. And so to make sure that this is happening, we need to understand how the drift develops below the rotor disc of a drone.
Drones are limited in their carrying capacity, and so there's still a use for helicopters.
Civil aviation require the aircraft to be high above the ground from a safety point of view. So we've been investigating the use of a suspended boom on a tether. So we've got a small ring boom which allows us to treat individual tree canopies fairly effectively, but the helicopter can still be reasonably high above that tree.
That work at Scion on incursion control is funding from the Forest Growers Levy Trust as an industry good project. The levy also funds $1 million worth nationwide of pest and disease surveillance to benefit everyone.
I've enjoyed it quite a lot, especially with the tutors to help us out, and even my peers in the class. Like, I'm 45 years old, but I get help from a 20-year-old. It's like a mixed package in our classroom. Like, there's experienced forestry workers, and then there's me, like just had like only worked for like 3 or 4 years in the forestry, and then we've got international students from India as well that are in the class with us, and they're coping quite well, and a lot of us help them out when they don't understand. I think it's not that they don't know what we're talking about, it's just it's put in English so for them to understand a bit more. I'd say to young Māori that it's not just a one job industry. There's you can get involved in either transporting, you know, it doesn't have to be management of just the forest, can be management of transporting or management of where the logs are going to be going, like to the end customer, and what they're going to be made into. There's like a whole wide range of things that they could be employed in. I'm mostly focusing on moving back to where I'm a landowner, back in the Wairarapa, and hopefully I want to be more into environmental things, like the environment down there, because there's around Lake Wairarapa there's a lot of regeneration that needs to be done to bring the quality of the water back up in the lake, and to go out into the streams and into the river, into the Rumahanga River, so those kind of things. Well, forestry sustains not only the community, but also the wildlife and the rivers that the dairy industry use, and the tourists come here to swim in our rivers and our lakes and walk through our forests and stuff. So it's not only about production of clear felling forest, it's on attracting tourists here as well, and sports. Like there's been a lot of sports events happening here in the redwoods forests. It's just as important as dairy, because a lot of the world come to New Zealand to buy our wood. So being such a small country, I think that's positive for us. And if the forestry dropped down and, you know, fell below a level that we could sustain China, Australia and all the other countries that want to export our wood to there, I think it would be just a domino effect on every other industry. Like not only forestry will be affected, like transport and sawmilling, and small towns may close, like even Rotorua. When a sawmill closes here, it has a big effect on the whole of the community.
And you might be interested in this, just straight off the print, the Tailgate Meeting Talking Topics Manual, pretty robust sort of thing that covers the issues that will come up in those tailgate meetings first thing in the morning. Just going through, looking at some at random, managing fatigue, personal protective equipment, reducing stress on your body, skid site management, traffic control, thinning to tree length rule, working alone, tree felling observers, working at height, working in hot weather, working in cold weather, and working with dust and fumes. All of those things that will come up at those tailgate meetings. So if you're a contractor, get on the Safe Tree website and score yourself a copy. $1.7 million hectares of our planted forests. Trees locking up millions of tonnes of climate change surplus carbon from the atmosphere, then storing it in our buildings. Standing forests binding the landscape, cleaning waterways and absorbing floodwaters. A sheltering habitat for our endangered birds. Forests as places to ride your bike, go for a run. Treescapes for a fun time, sweat or relaxation among the trees. Love our forests.
Kia ora, my name's Alfred. I work in the forest industry in the Bay of Plenty, and I'm a regional forester. The thing that fills me with the most pride is the fact that I know I'm working in a sustainable industry. I want to be able to influence how we grow forests in New Zealand. I'm out and about in New Zealand's landscape. The forests that we manage cover vast areas, and so your ability to have an impact on the landscape is huge. If you're young and starting out and wanting to get into forestry, get in touch with the Future Foresters.
At the time when the levy was being suggested and discussed, we were gathering a lot of information about getting ready for harvest of our first forest, and it just seemed to me that it was a well-structured and pertinent, timely. It comes in, they take the money at the time when you harvest it, So that's a good time when there's money going through the system. The group set up represents large and small forest, and so I just think it's an industry good body which we should all support. You just got to look at some of the projects being supported. You know, I mean, there's a lot of alternative species research being done, which is great, and that's certainly dear to the heart of small forest growers. So it'd be nice to think there'd be 2 or 3 species that you could select, you know, for the right site and that sort of thing. So I think that's valuable research. Also, I mean, the vast amount of forest planted in New Zealand is on pretty steep land. So that steep land harvesting research is, you know, I think is well worthwhile. Certainly when you've harvested a flat block and then you harvest a hill country one, you see the difference in net return. So anything that can, you know, make steep land research more, steep land harvesting more efficient has got to be good.
That's Forest Call for this time around. We'll be back with another episode, same time, next week. Ka kite. The answer indeed lies in the soil, the specks of dirt in the soil structure. In here, however, there's something else, an extraordinary organism called mycorrhiza. The role of this fungus in helping trees grow better is well known, understood and appreciated. But until now, on any scale at least, we didn't know how to make the life of that mycorrhiza a little easier. At planting time, we can do that, so that in subsequent years below the ground, the relationship between the mycorrhiza and the tree roots is healthier, in turn leading to more vigorous growth of the trunk which we harvest above the ground.